Hey guys, welcome back to the DevOps and Data Simplified. If you have been working in the ops for a while, someone almost certainly walked up to you and said, we need to add AI to this. And maybe you nodded and then quietly thought about it. What does this actually means for me? Well, here is the good news. You don't need machine learning degree. You don't need the math at all, because underneath all the hype, a large language model is just a service, a stateless inference service. And the moment you see it that way, scaling it, securing it, paying for it starts to look like the problems you already solved. So let's break it down. A quick word on why I'm making this. If you go on looking for the AI tutorials, almost all of them are intended for the app developers or the beginners. What almost nobody covers is the operational side of it. How do you deploy this? How do you scale it? And how do you stop leaking the secrets? And last but not the least, how do you keep it from quietly running up a bill that makes your finance team call an emergency meeting? That's the gap, and that's this whole series. I'm going to teach the AI the way I wish someone had taught it to me, from the point of view of the person who needs to keep it running in the production. So if you run the infrastructure for a living, you are exactly in the right place. So let's start with the word that gets thrown around constantly but never explained: inference. Every model has two phases in its life: training and inference. Training is the part you have heard scary numbers about. Thousands of GPUs, weeks of compute, and that is the process that builds the model. Think of it as a very expensive Docker build. It runs rarely. It produces a single artifact. The phase you actually live in called as inference. Inference just means that taking that finished trained model and just running one request. That is it. Every single time you call an AI API, that is an inference. Training builds the artifacts, and inference is a container running in prod serving traffic. Now the thing that runs the inference has a name: the Inference Engine. It's just the runtime that executes a model on the hardware. It loads the weights into the GPU memory, runs the computation, and streams the answer back to you token by token. You'll hear the names like vLLM, TGI. Those are the heavy-duty GPU grade engines, and Ollama or llama.cpp, which are light enough to run a complete model on your own laptop. When you call a hosted API like Anthropic's, there is an inference engine running behind the endpoint. You just don't have to manage it. But the day you decide to self-host, running that engine becomes your job. So let's go through a few mental models just to set the context. And back to the main idea that LLM is a stateless inference service. Now let's break both of the halves. First, inference service. The model itself is a big frozen artifact. It's immutable, and you can version it exactly like a container image, like Claude Sonnet 4.6, Llama 3. whatever. Running an inference engine is just running that image. Now to the important word, stateless. The model does not remember anything in between the calls. Absolutely nothing. Each request is completely independent. The same way you would assume that request number 2 does not know anything about the request number 1, unless you have passed the state along the next request by yourself. Everything the model knows at that given moment has arrived in the request. Nothing carries over on its own. Let me prove it to you. But before that, you'll need your own API key. Let's see how we generate it. So in order to obtain your own API key, you'll need to go to console.anthropic.com. Okay, as you can see, I'm logged in over here, but in case if you have not logged in, you'll have to go ahead and sign up first, log into it. Now, once you log in, make sure you have some amount of credits. Okay, you can go over here to the credits. You can click buy credits, and you can buy a minimum amount of $5 as a credit. And that way you'll be able to utilize the API key. Once you bought the credits, you need to go to the API keys and you'll need to click create key. You can just give a name, set the expiration date. As you can see, I have already created a key which I'll be using for this demo. Okay, once the key is set, you'll have to come back to your terminal, export the key in an environment variable. Now that you have your own API key, let me show you what stateless actually looks like. So in this demo, I'll send two requests to the model. In the first one, I'll mention a small fact about me, and in the second one, I'll ask model to reiterate that fact. Let's see. So as we have already created our API key, now let's go ahead and start using it. I'll just simply put a curl request over here. Now as you can see, I am calling the api.anthropic.com. These are my headers. Under the headers, I'm passing my API key. As you can see, under the environment variable Claude key, I have my key stored. Okay, and in the message under the body, I'm passing the role as user, and this is the content or the question I have. My name is Kalpesh. Just say hello back. So let's see what happens. Yep. As you can see, there is this response where the type is message, role is assistant, and this is the content. Okay, hello Kalpesh, hope you're doing well. Now you all know that I just mentioned my name in this request. Let me go ahead and execute another request over here. Okay, I'll have this same curl request. I'll only change the content and I'll ask it a question. What is my name? I'm executing it. As you can see, the response is, I don't know your name. You haven't shared that information with me, and I don't have access to any personal details about you. As you've seen, it doesn't have any idea. But it just told me my name 30 seconds before, right? That's not a glitch. That's the entire point. The server kept nothing. The first request and the second request are total strangers to each other. That is what stateless means. So, if the model forgets instantly, how does a chatbot holds on to a conversation? How does it remember what you said 3 messages ago? Well, here is the secret, and it's a letdown in best possible way. It doesn't. But you do. The client or your code keeps the entire conversation and resends the whole transcript on every call. The model's memory is just you handing out the entire history to it again and again. Let me show you how. Now what I will do is I'll go ahead and I'll create a context window. That means I'm modifying the message part a little bit. Okay, I'm sending the entire history of the conversation that I had with it. First of all, as you can see, the message part has 3 messages that are happened to and fro. Okay, the first one is with the role user. Content is my name is Kalpesh. Okay, that is I'm just telling it my name. Okay, the second response to that is via the assistant. So that is why I kept the role as assistant, and then content is hello Kalpesh. Okay, now I'm asking it what is my name. Okay, so let us say what happens. As you can see over here, your name is Kalpesh, as you mentioned earlier. Well, there it is. Now it knows my name, not because it remembered, but because I included the earlier turns right there in the message. It is I who carried the state. The model did nothing. It just read it. And that gives us one term that you will hear constantly. Context window. That is simply maximum number of tokens you can fit in a single request. Again, it's not the model memory, it's your request size budget. So when someone says a model forgot something from earlier in a long chat, what really happened is the transcript grew past the budget. Now let's come back to those tokens, because for you that will be the most important number in this space. Token is just a chunk of text, approximately a 3/4 of a word. The model reads token and writes token. And here is the ops relevant part. The token is the base unit for everything. You pay per token in and per token out. If you have ever done capacity planning around bandwidth or the data transfer, this is the exact same muscle. The tokens are the new bytes on the wire. we will do a whole episode just on controlling the token spend, because that's where the money quietly disappears. Next thing that surprises people coming from the systems background, this thing is not deterministic at all. That is, the same input does not guarantee the same output. There is a dial called as temperature, which controls how much randomness should go in a response. Higher the temperature, the more varied and creative it is, and lower, the more focused and repeatable. Let me show you how. Okay. Now, see this curl request. Over here, I'm mentioning the message as give me a creative name for my Kubernetes cluster. Reply with just the name. Okay. Now, you'll see that I am mentioning the temperature as 1.0 over here. Now, let us see what the response is. Okay. It has given me Nebula Nexus. Let me go ahead and clear my screen and we'll execute the same curl request once again. And over here, now I'm getting Nebula Craft. So for the same exact request, I got two different responses. Now let me turn down the temperature to 0 and hit this request once again. Okay, it is giving me Nebula Nexus. What about if I hit it again? Same thing, Nebula Nexus. As you can see, it is much more consistent, but, and this actually matters, even at 0, it is more repeatable, not a guaranteed pure function. So let me say the quiet part out loud. This breaks a lot of your assumptions about testing and reproducibility. Now to the last mental model, and it's the one that will save you the most of the pain. When one of these models is wrong, it does not tell you that it is wrong. There is no exception, no stack trace, no HTTP response code 500 at all. It will hand you a completely made up answer with full confidence. Well, this has a name. We call it as hallucination. And the reason I'm flagging it now is that it changes about how you think of the reliability. You can't trust the output just because the call succeeded. The call will always succeed, but verifying what comes back is on you. That is a design problem we'll keep coming back to across this series. So friends, that is the foundation. In the next episode, we will take everything from here and build a real working AI agent. No framework, nothing hidden, so you can watch the entire loop with your own eyes. If this has made LLM feel less like a magic and more like a service that you could actually run, do me a favor and subscribe to this channel so you catch rest of the series. Thank you friends. Have a good day. Bye-bye.